All right, let's dive into one of the most fascinating stories in programming language design right now, Zig's epic journey with async. Seriously, it's a tale of a brilliant idea, a really painful sacrifice, and this bold rebirth that's making a lot of us rethink how we write concurrent code. We're going to look at what Zig used to have, why it was ripped out, and what's rising from the ashes to take its place. But first, to really get why Zig's story is so compelling, you have to understand the big bad problem it was trying to solve in the first place. You can think of it as the villain of our story. It's a challenge known across the programming world as function coloring. So, what exactly is function coloring? Well, imagine your code suddenly has two kinds of functions. Let's call them blue for your regular, everyday functions, and red for your special async ones. Now, the problem, which you've definitely run into in languages like JavaScript or Rust, is that these two colors just don't mix. A red function can call a blue one, no problem. But a blue one can't easily call a red one. And that creates this rigid, annoying divide right down the middle of your entire code base. And this is where you really start to feel the pain. People describe it as a virus for a reason. The second you decide one little function needs to be async, that color has to spread. The function that calls it, it has to become async too. And the one that calls that one, yup, also async. It just keeps going all the way up the call stack. A single tiny change can literally force you to refactor huge chunks of your project. It's a massive headache. So, facing this problem, Zig came out with its first attempt at a solution. And it wasn't just another async await clone. It was this incredibly ambitious and frankly beautiful idea that aimed to solve function coloring once and for all. The big idea was to make the language completely colorblind. The dream was that you could write a single function, no special keywords, no weird syntax, and it could be used in a blocking, synchronous way or a non-blocking, asynchronous way. The function itself had no color. The choice was entirely up to whoever was calling. And when you put it side by side with the traditional models, you can really see just how different Zig's philosophy was. Instead of those viral async and await keywords that take over your code, Zig had this source-level colorblindness. Instead of hiding memory allocation, Zig made you deal with it explicitly, right on the caller's stack. And the real kicker? The choice to be sync or async happened at the call site, not when you first define the function. This quote really gets to the magic of how it all worked. It talks about a reified stack frame. Okay, what does that mean in plain English? Think of it like this. Normally, when a function is running, its local variables and state just vanish when it returns. With Zig's system, the compiler could essentially take a snapshot of all that state, package it up into a real object, and hand it back to you. You could literally pause a function, do something else, and then resume it later. It was incredibly powerful. But then, it was gone. In what felt like a really dramatic move, this feature that so many people loved was completely ripped out of the language. But here's the thing. This wasn't seen as a failure. It was a strategic sacrifice, one that had to be made for Zig's long-term health. So why do it? Well, it turns out that this clever feature came with a ton of baggage. It was deeply woven into the LLVM compiler backend, which Zig has been planning to move away from to achieve its famous fast compile times. The old async was slowing down debug builds, it made debugging a total nightmare because the information would get garbled, and it was tied to a bunch of old compiler code. To move forward and stay true to its core values of speed and simplicity, Zig had to let it go. And as you can imagine, this created a lot of uncertainty in the community. The old system was gone, but the new one wasn't there yet, and developers were left wondering what was next. You saw comments just like this one, with people being genuinely skeptical about whether any new solution could ever live up to the elegance of the original. After years of redesign, the new solution finally started to emerge. And in a really interesting twist, it wasn't a language feature at all. Instead, it was a new library pattern, built on the principles Zig developers already knew: explicitness and control. This was the start of the next chapter. This is the fundamental shift, the big aha moment. Instead of relying on compiler magic, Zig's new philosophy is that I/O is just another resource, like memory. You're probably familiar with this. In Zig, if a function needs to allocate memory, you have to pass it an allocator. Well, the new idea is exactly the same. If a function needs to perform I/O, you just pass it an IOTA interface. It's a pattern that's already second nature to Zig developers. So what does this actually look like when you're writing code? It's a really clear workflow. Way up at the top of your program, you decide how you want I/O to work. Maybe you pick an implementation that uses a thread pool, or maybe one that uses an event loop. Then, you just pass that I/O object down to the functions that need it.
From there, any function can kick off an async operation and await the result without having a clue about the underlying implementation. It's super clean.
And this brings us to the really bold claim from supporters of this new model. The argument is that by making I/O an explicit parameter you pass around, the whole virality problem is finally gone. A single function can now, in theory, work perfectly in a blocking context, a threaded one, or an evented one, achieving an even deeper kind of colorblindness than before.
So, with this new system taking shape and proving itself, all eyes in the Zig community are now on the next major milestone for the language, the official 0.16.0 release. This release is basically the culmination of this entire long journey. This is the moment when the SD.io interface goes from being a promising new idea to being the official, stable, and recommended way of handling all input and output across Zig's entire standard library. It's a huge step. And the excitement in the community is palpable. You see comments like this all the time. Developers are already dreaming about the kinds of incredibly flexible libraries they can build, like a web server that could be switched from running on a thread pool to an event loop without changing a single line of its core code. The potential here is just enormous. But let's be real, this new approach isn't without its critics, and there's a healthy debate going on. On one side, people praise it for being so explicit and truly colorblind. But on the other, there are really valid concerns about ergonomics. Is passing this I/O object everywhere just a new kind of boilerplate? Does it introduce its own new complexities? And that leads to the big philosophical question. Have we really defeated function coloring, or have we just given it a new name? Ultimately, Zig's entire async journey, from a clever compiler feature to an explicit library pattern, really highlights a deep truth about programming. There are no easy answers, there are only trade-offs. This new path is bold, it's principled, and it raises fascinating questions for all of us. Is the future of concurrency not about more compiler magic, but about these explicit library-level contracts? Well, only time, and the real-world code that developers write will tell if this is truly the final chapter in the long war against function coloring.